And then we have these numbers. We have 132. It's divisible by 2, 66, divided by 2, 33, divided by 3, 11. 11 is a prime number divided by itself to give 1. 16 is divisible by 2, 8. 8 divided by 2 is 4, divided by 2 is 2, divided by 2 is 1. And then we write them in this form. 132 equals 2 squared times 3 times 11. 16 equals 1, 2, 3, 4 equals 2 to the power 4. In the table we put the primes. We have 2, 3, and 11. 2, 3, and 11. For the number 132, we have 2 squared, 3 power 1, and 11 power 1. For 16, we have 2 power 4. We don't have 3, so it's better to put 3 power 0 and 11 power 0. And then to find the GCD of this pair of numbers, 132 and 16, the GCD, we take the prime factors with the smallest power, the common ones. So we take 2 power 2, 3 power 0, and 11 power 0. So the GCD is 2 power 2 is 4. 4 times 1 times 1 is 4. To calculate the LCM, we take the highest power, 2 power 4, 3 power 1, and 11 power 1. So 2 power 4 times 3 times 11, which equals to 528. In this exercise, we have 2206. It's divisible by 2 to give 1103, which is a prime number divided by itself. On the other hand, we have the number 1418. It's an even number and it's divisible by 2. It gives 709, which is a prime number divisible by itself. And then we put in the table the primes. We have 2 and 709 and 1103. For the first number, we have 2 power 1, 709 power 0, and 1103. For the other number, we have 2 to the power 1, 709, and 1103 to the power 0. And then to find the GCD, we have to take the prime factors with the lowest power. Here we have the power 1, and here to the power 1, as the same here and here. So we take 2 times 709 power 0 or 1 times 1103 power 0 or 1, which equals to 2. To find the LCM, as we said, we take the powers with the prime factors with the highest power. So 2 to the power 1 times 709 to the power 1, this is 0, and this 1 is greater than 0, so 709 power 1 times 1103, and it equals to 1,564,054. In this example, we have the number 3064. It's an even number. It's divided by 2, 1532, 1532, it's even, so it's divisible by 2. 766, also it's even, it could be divided by 2. 383, which is which is a prime number, it's divided by itself. On the other hand, we have the number 520. It's an even, divided by 2, 260. Also, it's an even, divided by 2, 130. 130 is also an even number, divided by 2, 65. 65, if we add the digits, the sum is 11, so it's not divisible by 3. We skip for 5. Yes, it's divisible by 5, since the ones is 5. 65 divided by 5 is 13. 13 is a prime number divided by itself. And then we write them in this form: 2 to the power 3 times 383. 520 is written as 2 to the power 1, 2, 3, 2 to the power 3 times 5 times 13. And then we write in the table the primes. We have 2, 5, 13, 383. We put them in an increasing order. For the first number, we write it in the table: 2 power 3 times 383 to the power 1, and here we have 5 power 0 and 13 power 0, since there is no 5 or 13 in this decomposition. 5 power 0 is 1. 520 could be written in this way: 2 power 3 times 5 power 1 times 13, and don't leave this empty, we put 383 to the power 0. And then to find the GCD of this pair of numbers, GCD, we take the prime factors with the lowest power. In this case 3 and 3, so we take any one. 2 power 3 times 5 power 0 times 13 power 0 times 383 power 0. All of them are ones. 1 times 1 times 1 times 2 to the power 3, which is 8. Then to find the LCM of the pair of numbers, we take the highest power. 2 power 3, 2 power 3, we take 2 power 3. 5 power 0 and 5 power 1, we take 5 power 1. 13 and 383, and we write them. We multiply them together to get 199,160.